Okay, I just wanted to make sure you're ready for your test tomorrow. Before I get started on going through the study guide, gentle reminder, you can use your Chapter 2 reference guide on the test. If this is not useful to you, make it useful to you. If you need to draw a picture beside postulate 2.1 in order to understand it better, do so. If you need to draw an example of the segment addition postulate so you'll know when you need to use it, do so. Make your reference guide useful to you. If you need to list that, for instance, 2.1 through 2.7 were all things we talked about in section 2.5 of our textbook, then do that. Make the reference guide useful to you. You get to use it on the test. On number 1, there's no way you're going to mess up that top line. The only option for segment addition postulate would be AB plus BC equals AC. The only thing I see that changes between line 2 and 3 is BC suddenly becomes DE. That would be substitution. We're substituting in DE for BE. This confusing bit right here was actually supposed to be pick out the different properties. It got copied weird. DE is congruent to DE congruent to GH. GH congruent to DE. That's symmetric. The symmetric property. Number 2 is the transitive. We end up skipping RS and going straight from AB to WY. So that's the transitive property. RS is congruent to RS. That is reflexive. We get to the next proof, which is a proof from section like 2.7. Number 1 was also from 2.7. That helps you with your studying. PR congruent to QS. That's given. There's no way you'll mess up line A. And might as well go ahead and fill in line G. P, Q, congruent to R, S. Okay, line B, they've dropped the congruent symbol. Anytime we drop the squiggle, we say that's definition of congruence. PQ plus QR equals PR. That sure does look like the segment addition postulate. Oh, but line D says segment addition postulate. We've seen proofs where we can use it twice because there's another line segment up here that I could write the segment addition postulate with. I could do it with QR plus RS equals QS. Now line E is the only confusing line. And anytime it's a confusing line like that, I'm normally guess it's either going to be substitution or transitive. If I'm not seeing it, it's probably substitution or transitive. If we look back at line B, we had PR is equal to QS. If we look at line C, we had PR is equal to PQ plus QR. So what happened on line E is we replaced the PR with PQ plus QR. We replaced it. Back on line B, we had QS equal to PR. On line D, we had QS equal to QR plus RS. So we're replacing the QS with QR plus RS. So anytime we're replacing someone, I think it's substitution. But I can also see, as I mentioned in class, how you could argue transitive. Now, the only thing I'm annoyed with in this proof is that there's not enough spaces in my mind. I think we need an extra space because I see subtraction property. So I think I should write PQ plus QR minus QR equals QR plus RS minus QR. I think we need to write that on its a whole line. In my mind, I need to change that to an H. And I need there to be a line G in between. I think there's an extra step. And next year, I promise on my study guide, I will add in this extra step. Mental note. Line G, the QRs finally cancel out, and I say PQ equals RS. And in my mind, that's substitution, because we're replacing the QR minus QR with a 0. And then line H is when the squiggle comes back in our congruent symbol, so we say definition of congruence. So that's really what it should be. So when you're turning in your paper, either line is acceptable in line F, because I get that you're trying to fit two things in one slot. Number 3, 4, and 5 are all from section 2.8, which is the section we discussed today, so I know you're a little nervous about it. First step says find the measure of each numbered angle. You can definitely do that. Angle 7 and angle 8 are a linear pair, so I know 5x plus 5 plus x minus 5 equals 180. 5's cancel out. So I have 6x equals 180. I divide both sides by 6. And I get x equals 30. And I would like an A on my test, so I check myself. 30 minus 5, that's 25. 5 times 30 plus 5, that's 155. 155 plus 25 really is 180, so I know I'm good. I did find the measure of the numbered angle. I didn't name the theorem that justifies my work. So there's a theorem that is allowing us to set those two angles equal to 180. I just need to reference it. If I look at my reference guide, I see theorem 2.3. It says if two angles form a linear pair, which 7 and 8 did in our example, then they are supplementary angles, meaning they equal 180 degrees. So I'm going to reference that theorem. So theorem 2.3, or the supplement theorem. Because it says if they're a linear pair, then they're supplementary. We have their linear pair, that's why they're supplementary. Awesome. Number 5 is going to be the exact same way. We have their linear pair, therefore they're supplementary. So again, I'm going to reference the same theorem. So theorem 2.3 / the supplement theorem. I need to add them and set them equal to 180. So 11x plus 10x plus 12 equals 180. 21x plus 12 equals 180. Give me a second to catch up. Subtract 12 from both sides and you'll get 21x equals 168. So x equals 8. I think it sure would be smart of us to check ourselves. We want the A. So 11 times 8 is 88. 10 times 8 plus 12, that's 80 plus 12, which is 92. 88 plus 92. Yep, we really do get 180. So I know I'm right. Number 4 is definitely not on the test. And the reason I know for sure it's not is because I studied and looked over my reference guide, and I can't find the theorem on my reference guide that justifies my work. I knew those 4 angles add up to 180 degrees. I know they make a line. So I wanted to just say definition of supplementary. I don't know. There's no theorem that I can find that I can reference that is on my reference guide for the test tomorrow. So we're going to have to let the theorem that justifies our work go. Although we still can practice adding them all up and setting them equal to 180. It won't hurt us. $19 plus 12. I get 31x minus 6 equals 180. So 31x equals 186. You divide both sides by 31, you're going to end up getting x equals 6. When I plugged it in is when things got interesting, because 5 times 6 is 30. 4 times 6 plus 6, 24 plus 6 is again 30. So angle 5 is 30 degrees, angle 6 is 30 degrees. 10 times 6 is 60. 12 times 6 minus 12, 72 minus 12, hey, that's 60. So I kept getting 60s and 30s. So it kind of reminds me 60 plus 30 is 90. So I wonder if there's a complement theorem that I can somehow stick on this problem, but I'm not really going to worry about that now because you and I are both worried about the test tomorrow. So we're going to let go of number 4 after this. On the back side of our study guide, we see another example from 2.8. Notice I put a lot of 2.8 examples on here. I just wanted you to have lots of practice because I doubt you're going to do that extra worksheet without me. We're given angle 1 and 2 form a linear pair. That's given to us. If you read the supplement theorem, it's on your reference guide. It's theorem 2.3. It says, if 2 form a linear pair, hey, we have a linear pair, then they are supplementary angles. So if angle 1 and 2 form a linear pair, that supplement theorem tells us angle 1 and angle 2 are supplementary. Or angle 1 is supplementary to angle 2. Letter C says angle 1 is supplementary to angle 3. Well, we knew that because they added up to 180. That was the definition of supplementary angles. You know supplementary angles add up to 180 degrees. And then even if you have no idea what's going on, there's no way you're going to mess up line D. Angle 2 is congruent to angle 3. The reason is that angles supplementary to the same angle are congruent, which is actually one of the theorems on our reference guide. And it is theorem 2.6. Or the congruent supplements theorem. But as explained in class, I'm kind of impressed if you're trying to guess the transitive property, because if you've noticed the pattern of angle 1 went with angle 2, angle 1 went with angle 3, maybe we can skip angle 1 and make 2 and 3 go together. So I'm impressed if you're thinking transitive. 7 and 8 I'm going to skip for the moment. I'm going to use the bottom of my paper for those. 9 through 12 are from 2.5. We've got to pick a postulate. Sometimes, always, never. You know I like the always and never ones. So sometimes ones I tend to leave off. I like life to be straightforward with the postulates for you. Something's got to be easy. Points J, K, L, and N are non-collinear and lie in the same plane. I say all that and then do a sometimes one. Okay, let's draw a picture. I got a plane M. I got J, K, L, and N. I read over my postulates. We have a postulate that says for any 3 points there is a plane. There's no postulate that says through any 4 points there is a plane. So I'm going to reference that postulate. So it's a sometimes. For sure the 3, we're not sure about the 4th. By postulate (2.2). Okay, we read the next question. It says they're exactly one line through points R and S. Okay, point R, point S, is there a line? And the answer is yes, because we know through any 2 points there is a line. Sorry about that. Okay. Through any, there's exactly one line 3 points are an S. Well, yeah, the first postulate, 2.1, says through any 2 points, there's exactly one line. So always, I have 2 points, so I have to have a line. Postulate 2.1. And then number 11 says line A contains only point Q. Well, that one is a never, for sure. A line has more than 1 point, and that's by postulate 2.3, because 2.3 says a line contains at least 2 points, not just 1 point, 2 points. Okay, back to our algebraic proof. Number 7 says we need a 2-column proof. We're given 12x plus 12 equals 48. Now over here on the side, I go ahead and work it out. $12x plus 12 equals 48. Subtract 12. 12x equals 36. Divided by 12. X equals 3. Woohoo. I just need to fill what I did in over here into my proof. So first step is going to be subtract 12. So 12x plus 12 minus 12 equals 48 minus 12. Subtraction. Next step is I did 48 minus 12 is 36. So 12x equals 36. I've replaced 48 minus 12 with 36, so technically that is substitution. Now I want to divide both sides by 12. So division. And then I want to replace 36 divided by 12 with 3. So again, I've done substitution. And I'm done on that one because I showed what I wanted to prove. Because it said complete a 2-column proof if 12x plus 12 equals 48, then x equals 3. Hey, I showed x equals 3 and I showed all my steps. I'm good to go. Okay, that was number 7. Now for number 8. We're given 4x plus 3 equals 52. Over on the side, I go ahead and work it out. 4x plus 3 equals 52. 4x plus 12 equals 52. I've distributed. Subtract 12 from both sides. I have 4x equals 40. Divide both sides by 4. You get x equals 10. Woohoo. I did the given part. The next thing I did over here was distribute. So I'll go ahead and do it here. 4x plus 12 equals 52. Distributive property. I then subtracted 12 from both sides. So 4x plus 12 minus 12 equals 52 minus 12. Subtraction property. $4x equals 52 minus 12 is 40. I'm replacing 52 minus 12 with 40, so technically that is substitution. I divide both sides by 4. That's division. And I replace 40 divided by 4 with a 10, so that is substitution again. I'm telling you, when I don't know, I guess substitution. awesome. I hope you're happier. Let me know if you have any questions. And since you've listened this far, let me give you some hints for the test tomorrow. There are 2 algebraic proofs. There are 2 segment addition proofs, 2 involving line segments. There's only 1 involving angles. Only 1. And I really think you'll do well. And if you have any questions, please come see me 0 period tomorrow. Okay, good luck.